The resistance of a galvanometer is 13 ohm. See, resistance of the galvanometer is equal to 13 ohm, and its scale is graduated for a current up to 100 ampere. 100 ampere, it means Ig is equal to maximum current in galvanometer. It means the galvanometer can show up to 100 ampere. It means that is graduated for ampere. It means it can the maximum galvanometer current is equal to 100 ampere. After adding a shunt to the galvanometer, see now we are adding a shunt to the galvanometer. See, this is the galvanometer. This is the shunt is added to the galvanometer. It means shunt S is equal to shunt resistance. This is main current. This is current through the galvanometer. This is I minus Ig, and this is main current I out. See, in a galvanometer, if this is an arrangement of an ammeter, if it is shunted, galvanometer is shunted, it means it is an ammeter. Ammeter. For an ammeter, we see this into this, that is Ig, current through the galvanometer into galvanometer resistance is equal to, because potential across this is equal to potential across this one, I minus Ig into S. That is, we can say Ig plus Ig into G plus S. G, this we take it this side, is equal to I into S. I into S, or Ig is equal to S divided by G plus S into main current. Okay, now what is this? This is also the shunt resistance constant, galvanometer resistance constant. It means this is a constant. It means galvanometer current is proportional to I. Now, as it is, we have seen in galvanometer, the deflection in galvanometer, already we have seen in the theory, the deflection in 8 is proportional to, deflection is proportional to current through this galvanometer. That is, Ig is theta is proportional to Ig, and Ig is proportional to I. Okay, now what is required here? Now we have to find the value of shunt resistance. We have to find out the shunt resistance. See, from here we can find out shunt resistance is equal to Ig into G divided by I minus Ig is equal to Ig. What is the value of Ig? Is equal to 100. G is equal to 13 divided by 100 minus, where I stands for the maximum. I is a galvanometer. After adding a shunt to this galvanometer, it's possible to read current up to 750 M. So I is equal to the range of the ammeter, 750 ampere. It should be ampere, it should be ampere. I is equal to 750 ampere, because here it is not matching the calculation. So I is equal to 750 minus Ig. Ig is equal to 100. Ig is equal to 100. This becomes 100 into 13 and divided by 650. We can cancel out this one. Is equal to 130 divided by 65. 65 into 65, it comes almost it is equal to, yes, not almost, exactly it is equal to 2 ohm. The shunt resistance to be added, a shunt resistance to be added. See here it is a question of a galvanometer given, a shunt is added, it means it becomes ammeter. We have to find out what is the value of the shunt, and then value of the shunt is equal to 2 ohm. A millivoltmeter of 25 millivolt range is to be converted into ammeter of 25 ampere range. See, first of all, let us see, this is the voltmeter. It means it will have a galvanometer G and a series resistance. This is the galvanometer. This is Ig is flowing. So this is the arrangement of voltmeter whose range is 25 millivolt. The range. It means what is range? A range for voltmeter. For voltmeter, that is how much PD, potential difference, it can measure. That is here range is equal to range is equal to Ig into the resistance. Range means potential difference across this is equal to Ig into galvanometer resistance plus the series resistance. This is the range of voltmeter. Now this voltmeter, now this entire thing is voltmeter, this is galvanometer, this portion is galvanometer. We will take this galvanometer only because this galvanometer is going to be converted into ammeter. Ig, it means we have removed it, it becomes a galvanometer because this is the voltmeter. We remove this portion, then this is become simple galvanometer. So Ig into galvanometer, Ig into galvanometer resistance is equal to V. That is for now at the moment this is equal to a range of voltage range of galvanometer. See here, this is range of galvan. This is the range of voltmeter. This is the range of galvanometer. It means because this we have removed, this became galvanometer. For this galvanometer, this is the range. Or Ig into galvanometer resistance G is equal to range of the galvanometer, or Ig is equal to V by G, where what is this? The voltmeter of 25 millivolt. So this is equal to 25 millivolt divided by G is the Ig now. The current which can be passed, maximum current that can be passed for this galvanometer is this much. This is the expression. Now this is to be converted into, this galvanometer is to be converted into ammeter. That means this is the galvanometer. We connect a shunt along with this. This is the galvanometer. We connect a shunt S, and this is I. Maximum current through which the maximum current can go through the ammeter, and this is maximum current the galvanometer can resist. This is I minus Ig. What is a range of ammeter now? This is ammeter. This is voltmeter. Ammeter, range of ammeter, that is how much current it can measure. I, this current, how much current it can withstand. I. So we can say from this equation, already from the equation, Ig into G, because potential across this is equal to potential across this for an ammeter, that is Ig into G is equal to I minus Ig into S, or Ig into G plus Ig into S is equal to I into S, or I is equal to, we can take G plus S by G plus S, Ig into S plus G is equal to I into S, or we were interested to find out I is equal to S plus G divided by S into Ig. This is the range of an ammeter. This expression is the expression for range of an ammeter. It means since I is equal to S plus G by S into Ig, where Ig, what is Ig? Maximum. Ig is equal to maximum deflection current of galvanometer. Three things are there. I, what is I? Maximum current that can be passed through the ammeter. This is Ig. So it means shunt resistance less the shunt resistance, more is the range, or more is the shunt resistance, less is the range. So it means we can from this equation we can see it depends on the range of the ammeter depends upon the shunt resistor. Now we have to find out what is the value of shunt required. So we can write from here shunt resistance. So shunt resistance is equal to G plus S and we have to find out the expression of the shunt resistance. S is equal to G plus S into Ig divided by I. This is the equation for expression for the shunt resistance. For the shunt resistance, Ig into G divided by I minus Ig. So this can be approximated to I. Why? This thing can be approximated to I because the current, this is Ig, this is I minus Ig. This is, since I is much bigger than I, the current flowing into the ammeter is much greater than the full scale diffraction current of the galvanometer. Therefore this can be neglected. Therefore S is equal to Ig into G divided by I minus 0 into I. So don't say why this cannot be made, because this is multiplied with something, 0 multiplied by something will become 0. So this we cannot remove, but this we can remove and substitute as 0. So this is equal to Ig into Ig into G. So this is equal to this, when this becomes 0, I. And what about I? See, Ig is equal to, see here for Ig is equal to 25 millivolt into G divided by I. What is the value of I? The value of shunt resistance required for the range of ammeter. So ammeter range means I is equal to 25 ampere. I is equal to 25 ampere. So I is equal to 25 ampere. What is the value of G? Galvanometer resistor. 25. Ig is equal to 25 millivolt divided by G into G divided by I. So this is equal to 25 millivolt divided by G. What is this G and this G get cancelled into I. What is the value of I? I is equal to 25 ampere. So this is equal to 25 into 10 to the power minus 3 volt divided by 25 ampere. Therefore shunt resistance is equal to 10 to the power minus 3 ohm, which is equal to 0. It comes up to be 1 by 1000 is equal to 0.001 ohm. This is the answer for this question.